we are going to solve a problem based on discrete time convolution. So here is the problem. So we have to convolve two signals. Which are given as h of n as an impulse response, nothing but n plus 1. But this exists between this range of n. And second is the input x of n, which is n square. This is also in the range of n from 0 to 2. Now first we will plot and then we'll get a y of n. So first I will show you how h of n will look like. So the values of n is from 0 to 3. And it is n plus 1, meaning for n equal to 0, h of n is 1. For n equal to 1, it is 2. For n equal to 2, it is 3. And finally, for n equal to 3, h of n will have the value 4. So this is a simple sequence h of n, which is nothing but n plus 1. And x of n is n square. And that exists from n equal to 0 to 2. So for n equal to 0, it is 0 square. 0 for n equal to 1, it is 1 square, which is 1 only. And for n equal to 2, it is 2 square, which is 4. So such a simple signal x of n we obtain, which is nothing but n square. And now for this we have to get an output which is given by y of n, nothing but x of n convolve with h of n. You can say h of n can also get convolved with x of n, meaning like a multiplication and addition, I can have a convolution also. So this time what we'll do, we will keep h of n as it is and we will shift this x of n and we will check what convolution we are obtaining. So the convolution sum formula is I can say x of n convolve with h of n, that is given by summation k from minus infinity to infinity x of k into h of n minus k. Or I can say this is same effect we will get if h of n is convolved with x of n. So this time formula will change like this: summation k from minus infinity to infinity h of k into x of n minus k. This is nothing but a y of n, which is output from this we are supposed to get. So we are going to do this. So what we'll do as a part of a first step, we are going to replace n by k independent variable. At the same time, we are going to take time reversal of this x of n. So here is the signals. So h of k will remain same like this. Which is nothing but k plus 1. And we are going to do a time reversal of this. Which will give us a signal like this. So this is x of minus k. Or I can say this x of minus k has shifted by 0 samples, so that very same sequence I can consider with a 0 shifting, so that I can check what is common between these two signals to get a convolution output. So over here, this I am getting common, but unfortunately here the signal value is 0, so I can say over here y of 0 is h of 0 multiplied by x of 0. So it is 1 multiplied by 0. In the end, I will get y of 0 equal to 0. So this is the convolution output I am getting for n equal to 0, which we can take and consider as the first output sample we got. Then it is quite obvious that for any shift, if I do in this direction, which I consider as a delay, where n is less than 0, I will not get any sample common. I will just show it for 1 or 2 samples like this. So h of k will remain as it is. What we are going to do, we are going to shift x of minus k by minus 1 sample, so that in the end we will get a signal which is starting from minus 3 and end on minus 1, and it will be like this. So this is x of minus 1 minus k. Similarly, if I delay it by 2 units, we'll get signal which is starting from minus 2 and it can go up to minus 4, the values as shown. So what we have done over here, we have shifted this by minus 1, this we have shifted by minus 2. In general, I can say what I have done, I have taken n less than 0. So for n less than 0, I'm not getting any samples common between this shift and this h of k. Hence I can say y of n is 0 for n less than 0. So I'll write over here no samples are common between h of k and x of n minus k for n less than 0. Hence I can say y of n is 0 for n less than 0. So now we have to just consider a positive shift, okay, of x of minus k. So in a positive shift, we will do it by shifting it by 1 unit. So for example, what we'll do, we will shift x of minus k by 1. So that resultant sequences will be like this. H of k will remain as it is. And we are advancing x of minus k by 1 so that we will get a signal like this. So what is this? This is x of 1 minus k. So if you see properly, we are getting two sample points common. And I can say here the value of n is 1. So we can say over here y of 1 equals h of 0 plus, repeat, h of 0 into x of 0 plus h of 1 into x of 1, which is nothing but 1 multiplied by 1 plus 2 multiplied by 0. So answer we obtained is 1. So the outcome of this is y of 1 I am getting as 1. Now let's shift it by 2 units. So the resultant signals will look like this. H of k will be same. Which is k plus 1. And we are shifting x of minus k by 2 units so that it will also start from 0. So this is x of 2 minus k. So what we have done over here, we have considered the shift is 2, so that we obtain y of 2. So the sample points which are common are this. So I can say y of 2 equals h of 0 into x of 0 plus h of 1 multiplied by x of 1, and one more sample point is common, hence it is h of 2 into x of 2. So if I substitute, I will get y of 2 as 1 multiplied by 4 plus 2 multiplied by 1 plus 3 multiplied by 0. And if we solve, we'll get an answer y of 2 equals 6. Now, this procedure we need to continue till the time this sequence will come over here. So what we have to do, for n equal to 3 also we need to check. So it will be like this. H of k will be same. Which is k plus 1, and now n equal to 3. So we will get a signal shifted by one more unit this side, meaning it will start from 1 and can go up to 3 with the values 4, 1 and 0. So this is x of 3 minus k. So what we have done over here, we have considered n equal to 3, advance x of minus k by 3, so that sample points which are common are this. And I say y of 3, now we can write it directly. It will be 2 into 4 plus 3 into 1 plus 4 into 0. So after solving this, I will get y of 3 as 11. Now further if I shift, still I will get a common points, hence we need to continue it. So for n equal to 4, let's see what will happen. H of k will remain same. Which is k plus 1. And now to get x of 4 minus k, we need to shift it by one more unit, previous sequence. That means this sequence we need to advance by one more unit, so that it will start from 2. Let's check out how many sample points are common. This is 1, and one more sample point which is common. So I can say now y of 4. Why it is y of 4? Because n this time it is equal to 4. So for n equal to 4, it will be 3 multiplied by 4 plus 4 multiplied by 1. So if you solve this, you will get y of 4 is 16. I guess we will get one more time we need to do this exercise because one more sample points will be common over here. So n equal to 5. Let's do it here. H of k will remain same. And this we need to advance by one more unit so that it will start from 3. Having the values 4, 1 and 0. So what is this? This is x of 5 minus k. So what we have done over here, we have taken n equal to 5. Now how many sample points are common? Only one. And what is that? N equal to 3 is the instant which is common between these two signals, so that y of 5 we will get 4 multiplied by 4 is nothing but 60. So y of 5 we will get equal to 16. Now if I have the shifting more than 5, nothing will be common. Let's take it for 1. So this time what we are doing, we are taking a shifting greater than 5. So let's see how the sequence will look like. H of k will remain same. And this time the signal is shifted by 6, that is more than 5. So it will start from 4. So it will be like this. So this is x of 6 minus k. So it's quite obvious over here. No samples common between these two signals for n greater than 5, hence y of n will be 0. I can say y of n is 0 for n greater than 5. Now in the end, suppose we need to plot this signal, how the signal will look like. So signals that we obtain will plot. So the plot of signal will look like this. For n equal to 0, it is having the value 0. For n equal to 1, it is 1. For n equal to 2, it is 6. For 3, it is 11. For n equal to 4 and 5, it is 16. And 6 onwards, it is 0. So you will get y of n like this. Now let's verify this answer with a tabular method. So for tabular method, we need a sequence, and we can obtain the sequence because we know h of n is given as n plus 1, and that is in the range of 0 to 3. So what I can do, I can consider this h of n as the sequence which is having a value 1, 2, 3 and 4 with the origin over here. Same thing I can do for x of n, which they have given as n square in the range of n 0 to 2. So I can convert this into a sequence like this: 0, 1, 4 with the origin over here. Now these are the sequences available, and we need to use this to get a convolution using tabular method like this. So over here I will have x of n and h of n like this. So x of n is 0, 1, 4 and h of n is, and I can write h of n as 1, 2, 3 and 4. So let's complete the table. It will be like this. Let's multiply this h of n with a 0 as the first element in x of n, so that we will get all the terms 0. In multiplication with 1 is 1, 2, 3 and 4, and finally multiplication with 4 will give us 4, 8, 12 and 16. So this table we need to segregate into a diagonal fashion like this. And then all these elements we need to add. So if you do this, we will get y of n as 0, 1, 6, 11, 16 and 16. And how to decide the origin? X of n is having a origin at this point and h of n having the origin at this point. So these 2 points are meeting at this particular element. So I can say this is n equal to 0. So this is the answer we obtained through tabular method, and this is the answer we got through graphical method, and both these answers are matching. So the technique that we used is correct. This is the end of a problem. Thank you.